Alright, so this is the PSSC demo video for Team 13, Beethoven's Ear, and our project is to create a MIDI transcription device that will take in raw audio from a musical performance of, say, a violin soloist, and convert it into an easily editable MIDI file. So what we've got here is our project. Right now it's in essentially a debug configuration. The way our project works, the majority of the project-specific success criteria are transparent to the user. They are the processing of data through the analog to digital conversion, the Fourier transform, the analysis of the Fourier transform to get the MIDI numbers, and finally the authoring of the MIDI file. The only thing the user cares about is that final file, but for the purpose of these demos, we're running it in a kind of a verbose mode that puts out a lot more data to demonstrate the various subcomponents. And so now what we'll go through now is a series of clips showing the different components of the system as they are embodied in the PSSCs. Alright, this is the test of PSSC2, which is the Fourier transform capability of our project. Basically what we do is we take in a window of 1024 samples, use an FFT algorithm from a library provided by Microchip, and then detect the maximum frequency component. What we're doing in this test is just testing on a simple sine wave that is 16 samples long for its period, and based on the sampling frequency that gives us a frequency of about 640 Hertz in that neighborhood. And basically what happens is plug it in, apply power, it runs pretty quickly. Since this is a DS-PIC, after all, it's optimized to run fast Fourier transforms and similar operations. Remove the SD card. And we bring up the test file that it prints out. Again, this is just a diagnostic form. The user would never actually see this, and it reports that the peak frequency is 640 Hertz, which isn't the exact frequency, but because of the way the bins are allocated for the fast Fourier transform, that's what it works out to be in this case. So this is the demo of PSSCs 3 through 5. Now, as we've said before, the actual workings of the device in normal operation are pretty much transparent to the user, so this is kind of a debug mode. What we've got on the SD card is some sample data that reflects what would come out of PSSC2, a set of frequency peaks that will then be worked on in PSSC3 to determine MIDI codes, which will then be in PSSC4 converted to a MIDI file before finally in PSSC5 being written to the SD card. And then apply power. So in debug mode, what we've got is just a single LED indicator to indicate when it is finished analyzing the data. It takes about 10 seconds since we're running through a few megabytes of file I/O from the SD card looking at the sequence of peak frequencies. Because our FFT runs pretty frequently, roughly every 128 samples, we're sampling at 11.025 kilohertz, this produces a lot of data for it to look at in the debug mode. Okay, so the LED indicates that it's done. We remove power, take the SD card back over to the computer. So what we've got here is two programs. One is HXD, which is a hex editor. We'll go ahead and open the file dump.txt, which is the dump of the MIDI codes. Now what you see here are hex versions of the MIDI, which is just the nature of hex. We can show you the conversions. And the other program we have is what's called MuseScore, which is a MIDI editor. And we go and open the MIDI file that was created on the SD card, and import it, and what we get here are the notes, and we can actually play this. and so that is the demonstration of PSSEs 3 through 5.